Welcome back to the Computing for All AI podcast, the podcast where we break down artificial intelligence concepts into digestible conversations. I'm Ava.
And I'm Davis, the AI enthusiast who's here to learn and ask all the questions our listeners might have.
And today, we're talking about one of the most fundamental, yet often misunderstood topics in AI: training data, test data, and the validation set.
Yeah, I've seen these terms thrown around a lot, but I always feel like there's some overlap. So, let's start with the basics. What exactly is training data?
Training data is the dataset we use to teach a machine learning model. It contains labeled examples that the model learns from.
So, if I were building an AI to recognize cats and dogs, will my training data be a bunch of images of cats and dogs, like with labels that say cat or dog?
Exactly. During training, the model looks for patterns in this data. Patterns like the shape of ears, for texture, or even subtle details in how cats and dogs stand.
Okay, so does the model recognize, like, ears, legs, and all the limbs?
Not really. The model does not look for ears, legs, or any limbs. It has its own way of finding distinguishing features from images.
So the model just memorizes everything?
Not quite. A well-trained model generalizes. It learns the patterns rather than memorizing the exact images. If it memorizes too much, that's called overfitting, and we want to avoid that. We discussed overfitting in the previous episode.
Oh yeah, that makes sense. But where does the validation set come in?
The validation set plays a crucial role. It's like a midterm exam for the model.
Midterm? So it's not part of the final evaluation?
Nope. The validation set is a separate chunk of data that helps us tune the model during training. After a certain number of training steps, we evaluate the model on the validation set to see how well it's doing.
Oh, so if the model learns well from the training data but performs badly on the validation set, it might be overfitting?
Exactly. Or it could be like, it is not yet trained enough, so it needs more training. After substantial training, a model that does great on training data but poorly on validation data has learned the training set too well. It's not generalizing to unseen data.
That's why we tweak hyperparameters like learning rate, dropout, and all that fancy AI stuff during validation. Am I right?
You got it. We adjust those settings to get better performance on unseen data.
Okay, now that I understand validation data, let's talk about test data. How's it different?
Think of the test set as the final exam. It's data the model has never seen before and is only used once training and validation are complete.
So, unlike the validation set, you don't tweak anything based on test results?
Exactly. You got it right. The test set gives us the final, unbiased measure of how well our model performs in the real world. If we adjusted the model based on the test set, we'd risk overfitting to that specific test data, which is not ideal.
So training is learning, validation is adjusting, and testing is the final check.
That's the perfect way to sum it up.
This makes sense now, but do you have a real-world analogy for this?
Sure. Imagine you're studying for a final exam.
Okay.
Your training data is like your textbooks and practice problems. You use them to learn. Your validation data is like taking quizzes or mock tests to see where you need improvement.
I see. And what about test data?
Your test data is the actual final exam, where you don't get to make any changes afterward.
Oh wow, that analogy really drives it home. So, if someone messes up how they split their data, what happens?
Great question. If you don't separate the data correctly, you might get misleading results. For example, if you accidentally include a part of the test data during training, your model might do great, but only because it saw those examples during training. That's one kind of data leakage, and it ruins the reliability of your model.
So, properly creating training, validation, and test data is crucial to getting a good AI model.
Absolutely. A common split is 80% training, 10% validation, and 10% testing, but this can vary based on the dataset size and application.
This was really helpful.
Also, remember that each split must contain a reasonable number of samples of each label.
That is, the training data must contain both cats and dogs. Similarly, the validation data should contain cats and dogs. Also, the test data must contain both cats and dogs.
Exactly. If your data labels are only cats and dogs.
Aha! I think I finally understand the difference between training, validation, and test data.
Awesome. It's one of those fundamental concepts that, once you get it, makes AI training much clearer.
So, if someone is building their first machine learning model, what's the biggest takeaway?
Always split your data correctly. Don't let test data influence training. And remember, validation helps with tuning, but test data should be untouched until the end.
Solid advice. Okay, what happens after satisfactory performance is observed on test data?
Great question. The model is ready to go to the wild and predict. That is, the model then can be used in applications to predict whatever it is trained to predict. There is no more labeled data.
Aha, a model in the wild.
And with that, we're wrapping up today's episode. If you found this discussion helpful, don't forget to subscribe and share it with your fellow AI learners.
Thanks for listening to the Computing for All AI podcast. See you next time.